Welcome back to Dead Reckoning, the Human Life Expectancy channel. Last time we showed how evolution is itself evolving from natural selection, coevolution, and sexual selection to volitional evolution, where human choice is increasingly guiding and accelerating evolution. In this video, we'll show the extraordinary progress volitional evolution has made and show that it's poised for even greater things in the future. We'll also suggest that one of the first things we choose will be to live longer, extending HLE going forward. So, the conscious volitional choice of Homo sapiens is now driving and accelerating evolution to wholly new levels. After all, if we have the ability to choose, we need only to decide what characteristics we want, and such decisions can be made far more quickly than any change driven by natural selection or sexual selection. Consequently, volitional evolution has advanced rapidly. Having applied conscious decision-making to selecting mates, humans then began to apply volitional evolution to other organisms. About 23,000 years ago, humans developed the ability to selectively breed other organisms to better serve their needs. Selective breeding is a form of volitional selection where we choose the characteristics to emphasize in a population of organisms whose reproduction we are actively managing. Although the selecting agent is man, not nature, the process is otherwise the same, but the pace of evolution accelerates greatly. Almost all domesticated crops and animals have evolved dramatically from their natural forms based on humans' volitional selective breeding. Plant cultivation began about 23,000 years ago in the Middle East with the selective breeding of edible cereals such as wild barley, wild oats, and wild emmer. Between 8,200 and 13,500 years ago, rice was first domesticated in the Yangtze River basin in China. It's since been bred to over 40,000 varieties that offer increased production, larger grains, and new types such as golden rice, which was genetically engineered to contain beta-carotene to improve eyesight. Today, it provides more than 1/5 of the calories consumed worldwide by humans. About 10,000 years ago, corn was domesticated from Teosinte in Central America by farmers in what's now Mexico. Today, corn has been bred into many different types. For example, sweet corns for human consumption and field corns for animal feed and to produce various chemicals. It's also been bred to have many more ears per plant, to have much larger kernels, to be more resistant to both flood and drought and many other criteria. Total corn production now exceeds wheat or rice. About 9,600 years ago, wheat was first cultivated in the regions of the Fertile Crescent. It started as a form of wild grass with small seeds that easily fell off. Today, wheat has been bred to have much larger grains that remain attached to the plant to facilitate harvest. And it's also grown on more land area now than any other food crop. Small wild potatoes were first domesticated in southern Peru approximately 7,000 to 10,000 years ago, and were introduced to Europe from the Americas in the second half of the 16th century. Following centuries of selective breeding, there's now over 5,000 different types of potatoes with different sizes, sugar, and fiber content. Later, around 2000 to 3000 BC, carrots were first grown for their aromatic leaves and seeds rather than their roots. Some close relatives of the carrot are still grown for their leaves and seeds, such as parsley, cilantro, dill, coriander, and cumin. In the 1st century AD, carrots began to be bred for their roots, which went from small, thin plant roots to large, thick, orange vegetables as we know them today. Then, around 1000 BC, horticulturists began to sculpt cabbage into Brussels sprouts, into kale, into broccoli, into cauliflower. Man also has an extensive record in the selective breeding of animals. In addition to the self-domestication of dogs discussed before, man also began actively breeding dogs about 9,000 to 15,000 years ago in Central Asia. Our ancestors found that some wolves picking through our garbage were friendlier than others. They started breeding the friendlier ones for their abilities to protect their homes, herd their livestock, and ultimately become companions. This process has resulted in the broad spectrum of dog breeds we see today. Today, dogs are the most variable mammal on Earth, with human volitional selection producing about 450 globally recognized breeds, all the way from Chihuahuas to Great Danes. We also began to breed cattle and oxen about 10,500 years ago. Wild aurochs, which evolved about 2 million years ago during the Pleistocene, were bred into over 250 modern breeds of cattle we know today. They've been bred for meat, for milk, their hides, and they're used for riding and as draft animals to pull carts, plows, and other implements. About 10,000 years ago, Neolithic farmers in Iran began to breed domestic goats, primarily for milk and meat, as well as for their dung, which was used for fuel, and their bones, hair, and sinew, which was used for clothing, building, and tools. There are now over 200 breeds of goats for dairy, for fiber, including Angora and Cashmere fibers, for meat, for trail packing, and even for brush control. Also about 10,000 years ago, man began to domesticate chickens. Today, chickens have dramatically changed from the red jungle fowl called Gallus gallus, from which they evolved. There are now hundreds of species of chickens that basically fall into two categories: layers, which are breeds raised to produce prodigious amounts of eggs, and broilers, breeds that are plump and meaty. Whereas the Gallus gallus laid only one egg a month to allow it to rear its young, today's chicken lay one egg per day. Today, around the globe, 60 billion domesticated chickens produce about 1.2 trillion eggs per year. Broilers have been bred to grow many times faster and larger than the Gallus gallus, so much so that some cannot even walk or stand up. Pigs were domesticated about 7,000 to 9,000 years ago, and were bred to become ever more docile and rotund. Today, there's over 180 breeds of pigs that are bred for lard, bacon, and pork. Horses were domesticated about 6,000 years ago and have now been bred into over 200 types of ponies, light breeds, and heavy breeds. So clearly, our volitional evolution of plants and animals through selective breeding has created an explosion in evolution over the last 20,000 years. However, it wasn't until much later, in 1865 to 6, that we began to understand the genetic principles behind inheritance of genes. This enhanced our ability to apply ever more sophisticated volitional selection techniques to plants and animals. In the late 1920s, the pace of volitional evolution quickened again when scientists discovered that they could increase the rate of genetic mutations by bombarding DNA with chemicals, radiation, and enzymes in a process called mutation breeding. This damage caused extensive and unknown changes to DNA that mostly resulted in unsuccessful and unviable organisms. However, some inevitably proved viable, and more to some people's liking. From an evolutionary perspective, it gave breeders of plants and animals a broader spectrum of mutations from which to choose, accelerating volitional evolution. Between 1930 and now, well over 3,200 so-called mutagenic plant species are released and are now common varieties of rice, wheat, barley, pears, peas, cotton, and many, many other foods. In 1962, plant geneticist Norman Borlaug introduced semi-dwarf wheat, which was an interspecies hybrid, in India. It now accounts for over 99% of the wheat around the globe. His efforts are thought to have saved over 1 billion human lives, earning him the title the Father of the Green Revolution and earning him the Nobel Prize in 1970. Volitional evolution then took another great leap forward just in the last 15 years with the development of genetic engineering. Genetic engineering allows us to modify and evolve genomes in real time based on our preferences and choices, further advancing volitional selection and volitional evolution. We'll describe the development and the applications of genetic engineering in much more detail in future videos. However, like sexual selection, volitional selection allows for the selection of characteristics that may not enhance survival. For example, the large udders and lack of horns on modern man-bred cows would make them unable to flee or defend themselves from predators in the wild. Pigs have also been bred to be so large and slow-moving that they would be easy and relatively tasty prey. The large white meat breasts that broiler chickens have been bred to have make the birds so heavy that their hearts and lungs cannot keep up, and many can no longer support their own body weight. Man's extensive inbreeding of dogs have left many breeds rife with health complications. There's clearly room for improvement. Labradors are subject to 30 genetic conditions. 60% of golden retrievers die of cancer. Beagles are prone to epilepsy. Cavalier King Charles Spaniels suffer from seizures and persistent pain due to their deformed skulls. Lovely as these creatures are, you should know this before you get one. Today, over 90% of the biomass of animals weighing over 1 kilogram on Earth is either humans or our domesticated animals. Genetic researcher and Nobel Prize winner Jennifer Doudna has said, quote, "Almost everything we eat has been altered by humans, often by generating random mutations in the DNA of seeds used to breed plants with desired changes. Thus, the distinction between natural and unnatural has been obscured. Red grapefruits created by neutron radiation, seedless watermelons produced with the chemical compound colchicine, apple orchards in which every tree is a perfect genetic clone of its neighbors, none of these aspects of modern agriculture is natural." We'll return to this theme in a future video where we discuss the dramatic inconsistencies in regulations of genetically modified organisms, or GMOs, versus common mutagenic organisms. The volitional evolution of human beings is also advancing rapidly. Our unique consciousness of our reproduction allows us to choose to follow our natural instinct to reproduce or not, furthering the advance of volitional evolution over natural selection. Humanity's consciousness changes almost everything about human reproduction. Per our last video, the recent global drop of human fertility rates is strong evidence that our thoughts are dominating our natural drive to reproduce. The rise of the importance of our thoughts over the imperative to propagate our genes is one of the most consequential developments in our species. In future videos, we'll show how this will transform human reproduction and even who we are becoming as a species. We'll see that our consciousness and increasing technological and medical abilities give us increasing power to choose how we and other species will evolve, either by selecting attributes for or by genetically modifying our offspring. We'll also explore the societal impacts of new life-extending technologies. Much of human society has been about allowing people to reproduce in an orderly fashion. Our increasingly volitional choice to have children or not to have children is perhaps the single most important driver of future global population and future society. With these almost godlike powers to extend the lives and sculpt the lives of future generations and other species, it's easy to see why great thinkers like Yuval Noah Harari have suggested that Homo sapiens might be evolving into Homo Deus. However, this overstates the advance. As we've shown, humans have been influencing the path of evolution for eons, only through the less effective means of sexual selection and selective breeding in plants and animals. As further evidence that we've been less effective, we've also shown that to date, our volitional evolution has resulted in many unhealthy animals. If we're going to curate the bodies and beings of dogs, animals, and even ourselves, shouldn't we hold ourselves to a higher standard and do a better job of it? With the power and choice associated with volitional evolution comes the responsibility to guide evolution in a wise and ethical manner. We'll argue that we must do this, and that genetic engineering and other tools will help us to get there. As we gain the power to modify DNA as we wish, the main questions remaining will be ethical and philosophical. Should we guide our own evolution and the evolution of other species? Toward what objective? Who decides? And what regulation should we have? As a result, volitional evolution both represents the highest expression of human capability and creates existential challenges. From an evolutionary perspective, we've gone from natural and sexual selection to increasingly volitional selection in the blink of an eye. We've gained the ability to select how we and other species evolve through ever more precise and rapid mechanisms. In a very real sense, our ideas, which evolve much more rapidly than our genes, are now guiding our evolution. In the future, choosing to live longer will likely be one of our first priorities. The ability to read and modify DNA, the genetic code that drives the evolution of all species, gives us an even more rapid and complete ability to choose how we'll evolve. This will almost certainly allow us to increase human life expectancy. It'll allow us to rewrite the human genome to cure many diseases and select for children without genetic defects. It even offers the prospect of curing aging itself. Some top doctors and scientists have taken to looking at aging as a disease to be cured. This could involve slowing, stopping, or even reversing the effects of aging. New genetic interventions actually make this much more viable. Based on current research, some scientists now believe that aging should be easier to cure than cancer and other diseases. This is not a wild claim. Scientists have already shown it possible to materially extend healthy life expectancies of other animals, and many think it's only a matter of time before we can materially extend human life expectancy. We'll show you that these technologies already exist, are advancing rapidly, and are becoming easy to employ and significantly less costly. There's many reasons to think that we'll leverage genetic engineering and other technologies to choose to live longer. First and foremost, the will to survive is our single most powerful instinct, and there's almost nothing we wouldn't do to save or extend our lives or the lives of our children or other loved ones in danger. Driven by our natural will to survive, we will surely continue to make decisions and take actions that result in the extension of our individual and collective longevity. Extending life expectancy is perhaps human society's most fundamental promise. In his book, Immortality, Stephen Cove observes that civilization is built on the promise of immortality. It's the ultimate objective of governments, medical professions, and public health efforts. Law, institutions, and governmental policies are all based on the right of the living to extend their lives. Large financial incentives will also drive the extension of HLE. Governments will want to improve the health of their citizens and save billions in healthcare spending. It also offers businesses and investors the prospect of making billions or even trillions of dollars in products and services that extend HLE and cater to our aging population. It's also a safe bet that many of us will want to continue to live longer. We'll also argue that it would be immoral not to increase human life expectancy where we have the ability to do so. And finally, genetic engineering is so easy and inexpensive that it would be virtually impossible to stop even if we wanted to. With a high school degree and kits available on the internet for little over $100, pretty much anyone can splice genes. As a result, we'd do better to address this opportunity squarely and plan for its effective ethical use. In our next video, we'll show that Homo sapiens has already used volitional evolution to make extraordinary advances in HLE. This is perhaps the best proof that we'll continue to leverage it to further advance HLE in the future. In the meantime, please hit the like button below, subscribe to the Human Life Expectancy channel to make sure you don't miss our next videos, and post comments for the topics you'd like to have us cover. Thanks for joining us. Till next time, as we say at Human Life Expectancy Inc., Hi Hua! Please, do what you can to help yourself and help us all to live longer.